Okay, so solving a distance, rate, and time problem, we have a whole bunch of different ways we can write the same equation that we know. So let's first look at, we know distance equals rate times time. We can also solve for the different letters, so I could get r by itself by dividing both sides by t. So d divided by t equals r, or I could have gotten the t by itself, so then I could have d over r equals t. Now, when we're doing these problems, generally what what form we want to do is whatever they're saying is at the same time or at the same distance, whatever is the same in both problems. So we have a plane has a cruising speed of 250 miles per hour when there's no wind. So we have things that we're talking about. We've got wind and we've got a plane, we've got the speed. At this speed, the plane flew 300 miles with no wind. In the same amount of time, it flew 200 miles against the wind. Find the speed of the wind. All right, so we have plane, we have wind, we have distance, we have time, and when we're looking at the plane has a cruising speed of 250 miles per hour. That's just the speed of the plane, 250 miles per hour. That's the rate. The wind, we don't know what that is, so we're going to call that x. Distance. So at this speed, the plane flew 300 miles with the wind in the same amount of time. So my time is going to be equal. Distance, we've got two distances. So 300 miles with wind and 200 miles against. All right, so looking at that, what the problem is telling us is we have two situations. One, the wind is helping us. One, the wind is hurting us. So we are going to go into our formulas. So we've got the time is the same. So I'm going to think about this one. And I know with wind, the time equals against wind. All right, so I've got the time equals the same both ways. So now I can actually look at this left-hand side of it, the distance over rate, and I'm going to look at each case. So with the wind, my distance is going to be 300 miles. Okay. My rate would be the 250, the plane, plus the wind, which is the x. Now that is going to equal, when I'm going against the wind, my distance is 200 miles. And this time my speed is going to be the plane, but this time the wind's not helping me, so it's going against the wind. So that's how I use the formulas of saying, okay, what case do I have? What's the same? And how can I solve this? And if I've got this, I've only got one thing that's missing because that time was the same. It kind of cancels out. So now I've got a fraction equals a fraction. I can cross multiply. So I have 300 times 250 minus x equals 200 times 250 plus x. I can solve this problem. It is like we've done way back yonder, distributing. So 3 times 25 is 75, and I have 3 zeros, minus 300x equals 200 times 250 is 50 with 3 zeros, plus 200x. I'm going to get the x's on one side and the plain old numbers on the other, so I'm going to add 300x to both sides. And then I'm going to subtract the 50,000. And then I have 25,000 equals 500x. Divide by 500. I'm going to cross out zeros, 2 and 2. 5 goes into 250, 50 times, so 50 miles per hour equals the wind. And it's a plane, so the planes do go quite fast and they are causing a lot more wind. All right, so the general formula, distance equals rate times time, you can solve for any of the letters, and which form we want to do is going to depend on what problem we have. So let's look at another one. I'm going to move it up so I have a little bit more space. All right, this time we have Brian swam 8 kilometers against the current at the same amount of time it took him to swim 16 kilometers with the current. The rate of the current was 1 kilometer per hour. How fast would Brian swim if there was no current? All right, so looking at the problem, we're looking for the current. So we have current, we have Brian, we have distance, we have time. All right, and it's the same amount of time. So time with current equals time against current. Using the formulas before, time by itself is going to be distance over r equals distance over r. Now my rate with the current is going to be, just so I can talk words, so distance Brian plus current equals distance Brian minus current. All right, so what we have with this, the current is 1 kmph. Brian swam 8 kilometers. I am looking for Brian, so that's going to be my x. Distance is 8 kilometers with, against, sorry. 16 kilometers with, and the time is equal. All right, so putting stuff into my formula, I have distance with the current is 16 over Brian plus current is x plus 1 equals distance against is 8 over x minus 1, cross multiplying. We have 16x minus 1 equals 8x plus 1, simplifying, distributing all that. So I have 16x minus 16 equals 8x plus 8. Get the letters on one side, numbers on the other. So I'm going to subtract the 8x minus 8x. That will give me 8x. I'm going to add the 16 because I want the numbers on the other side. Equals 16 plus 8 is 24. Divide by 8. And we get x equals 3 kilometers per hour. So Brian is swimming at 3 kilometers per hour. All right, I think I have one more that we can do. Yep. So we'll look at this last one. All right, still same formulas that we have from the very beginning. We have distance equals rate times time, distance over time equals rate, and distance divided by rate equals time. So reading the question, we have a cyclist travels 10 kilometers per hour faster than an inline skater. In the time it took the cyclist to travel 40 kilometers, the skater has gone 20 kilometers. Find the speed of the skater. So looking at a problem, we have a cyclist. We have a skater. They're talking distance. And they're saying time. The time is equal. All right, which tells me I'm going to have my formula time equals distance over rate. Looking at my cyclist, 10 kilometers per hour faster than the inline skater. So inline skater is going to get x, and this is going to be x plus 10 for my rate. This is my rate. My distance is, it took the cyclist to travel 40 kilometers. So my distance for the cyclist is 40. The skater goes 20. All right, and there's a whole bunch of different ways that you can organize all of your information. I like to get rid of the words as much as possible, but keep things in charts is what I'm looking at. So I know the skater time equals cyclist time and then putting stuff into the equation. So I've got the distance over rate equals distance over rate for the different cases. The one that I'm looking at, skater, the distance was 20 kilometers. And the rate for the skater is x. The distance for the cyclist is 40. And the rate is x plus 10. Yet again, cross multiply, because that is when you have fractions equal to fractions, you can cross multiply, or you can get a common denominator. So 20 times x plus 10 equals 40x. All right, so distributing 20x plus 200 equals 40x. Get the x's on one side. I get 200 equals 20x divided by 20. This is 200 divided by 20. X equals 10. Okay, let's find the speed of the skater, 10 kilometers per hour for the skater, because that is 10. And the cyclist would then be 20 if I needed that.